Welcome to Homework Lib.
Okay, so if we look at the diagram on the right, we start from this one, and that's the initial setup of the circuit. And then if we start from the extreme right side, we see that these three resistors are in series connection. So if we try to find the equivalent resistance of that, it's going to be 3R. So this circuit is transferred to this, and that's the equivalent resistance that we can find. Since it's a series connection, it's 3 times R. Now from there we know that again we are going from the left, from the right, so these two are in parallel connection, so we need to find the equivalent resistance for them. So let's call it Req1. So we're trying to find the equivalent resistance of this part. So that's Req1. Let's name it. And this should be equal to 1 over R plus 1 over 3R reciprocal, which is equal to 3 over 4R. So that part is 3 over 4R, and as you can see, I've written it there as well. Now these three guys are in series connection again. So if that's a series connection, it should be, let's mark this part and let's call it Req2, and Req2 is going to be, so it's twice of R plus this quantity, which is 3 over 4R, and that gives us 11 over 4R. And if you can see, I replaced these three guys by that exact same quantity. So the final equivalent resistance will be, so before we go to the final, we have to make sure we get the equivalent resistance of this guy. So let's call it Req3. So Req3 is going to be, so it's a parallel connection, so that's going to be 1 over R plus 4 over 11R reciprocal, and that gives us 11 over 15R. Right. So now if we replace this guy, we should have a pretty straightforward circuit like this. And this is going to be A, this is going to be B, this is R, this one is R, and this one is 11 over 15. So going by the same logic, this is a series connection. So the final answer, or the final equivalent resistance, will be, so twice of R plus this quantity, which is 11 over 15R, and that gives us a total resistance of 41 over 15R. Now since we know the value of R, which is 175, we can evaluate the expression. So it's going to be 41 over 15, and R is 175 ohms, and so the final answer is going to be 478.33 ohms. So yeah, that's the equivalent resistance across the point A and B. For part B, we need to find out the current. So first, let's find out the total current that's passing through the circuit. So we know that if we start from this point and then go towards the circuit, we see that these two guys will carry the total current because uh, these two guys are in series with this whole thing. So the total current will be the current that's passing through these two circuits, these two resistors, and that's gonna be V over R EQ, and we know that V is 50 volts. It's gonna be 50 divided by 478.33 ohms, and that finally gives us 0.10453 amps, or if we approximate it, it's gonna be 0.105. Now that's the current, as we mentioned, passing through the top and bottom part of the resistor, and then there will be less current on these parts because the current is splitting, and with the same current passing through the resistor in question and the rest of the current passing through the equivalent resistance of 11 over 4R must be the same since they're in parallel. So this current and the current passing through this guy should be the same, right? So from this figure right here, we can say that the desired current, um, we can use the fact that the voltage across this 2 points, the voltage across this resistor and this one is the same. So it's going to be V over R, which is equal to V over 11 by 4R. And if we use Ohm's law here, we'll get something like this. So V equals I times R, that's what we're using. So current of 11 by 4R resistor times 11 by 4R. Right. Now that is nothing but the total current minus the current that's passing through R times 11 over 4, because as we mentioned that the current is going here and then it's splitting, so the total, so if we subtract the total current from this guy, we get this current, and that's what we did here. And if we plug in the numbers, we get something like, if we solve for these two guys, we get something like I over R, which is equal to 11 over 15 I total, right? And since we know the value of I total, we can put that number, and that gives us our IR as 11 over 15 times 0.10453 ampere, and that comes out as 0.0767 amps. So let's see, what is the current through each of the three resistors on the left? So these are the three resistors that we were calculating. So for these two, let's actually mark it. Let's say this one is 1, this one is 2, and this guy right here is 3. So for the first one, it's the total current, which is 0.10453 amps. Yeah, and for I2, it's the same, and I3 is 0.0767 amps. Thank you.